The other thing I wanted to show you was encapsulation, which is what all these little P somethings are. These are encapsulated or sub-patchers. So if let me go back into send and receive. If for some reason I wanted to take all of these things and put them into one sub-patcher for organization or convenience or to reduce this amount, all I have to do is highlight everything, go to Edit, Encapsulate, and it will put it into a sub-patcher, just named P. I can then name this whatever I want to. I'm going to call it SR. So that's my PSR. And now if I lock my patch and double-click it, it'll open up and show me what's inside there. Mm-hmm. Mm-hmm.
I tried, mine was not working. It would have like a little arrow thing showing that it's supposed to go somewhere else, and then it was like they weren't connected anymore.
Right. So a problem you might have is if you try to encapsulate things that are connected, right? So if I try to encapsulate just the send and the hello, the send and the receive here, it should be smart about it, and it's going to stay connected. And if we look at this now, it added this one and this one here with the one and the arrow going in and the arrow going out. This is called an inlet object. I can make another one by typing inlet in a new object. It will number that 2. I could do the same for my outlets. I could say outlet. It'll give me another one of those. And then if I look back here, you'll see now I've got 2 inlets and 2 outlets. And so that's what that is. And the numbers correspond to the order, left to right, as we go across.
Left to right, not right to left.
Yeah.
Oh,
Yeah.
Okay.
But you can remember that by just looking at here, because the numbers will change dynamically too. So if I move this one, this is wild. If I move this one over here, it becomes 2, and if I close it, it's going to keep my cord connected the right way. So I can move them around. And again, it helps. You don't have to name these things, but for your own sanity, it helps to name them so you can keep them straight. Now, these are not like objects or like instances. So if I copy and paste this one a bunch of times, right? If I open these all up, they're going to be the same because I just copied and pasted them. But like if I go to this third one and edit it, and I take out the bottom part, all right, and close it. Woohoo! Haha. And go back to the first one still has that. The second one will still have it. The third one is unique in that it doesn't have that. I've removed it. This can get confusing because these all have the same name because I just copied and pasted them. So you have to be careful if you're making like multiples of stuff. Okay, so that's encapsulation. The other thing I wanted to show you was presentation mode. If I look at the very bottom of my Max window, on the bottom left, there's a little like display screen button, I think is what this is supposed to be, near the lock. And if I click that, my patch is going to go into presentation mode. And you'll notice I have nothing here. What I can do with presentation mode is set things that I want to have in my UI that I don't want to have in the rest of my patch. So a good example of this, if I look at my camera section, there's a lot of stuff going on here that isn't essential to my understanding of how this patch works. So if I wanted to clean this up for myself or a user, if I'm going to give this software to someone else to use, they're going to see all this and feel really intimidated. What are the important things that they're going to need from this? They're going to need the toggle. They might want the preview window. So I'm going to hold down Shift and select a couple different things. They're going to need the Get Dev List button, this drop down, and the Open and Close buttons. But that's really it. I'm going to right click on those and say Add to Presentation. I can also access that in the inspector. If I open up the inspector, I might have to do this on an individual basis, yeah, but I can select one object, and if I go to All, it's going to say Include in Presentation, and that's checked now. If I want to remove it, I can uncheck it, check it to add it again. You'll also notice when something's been added to the presentation, it has a kind of very light pink border. You see that? That's so that when you're in edit mode in your patch, you know that those things are in the presentation. So now if I click presentation, those things stay there. Everything else goes away. It's hidden. And I can now drag these things around to make a nice, quasi-nice UI for my patch. I can resize things even, like that patch, this P window I'm going to make a little bit bigger. And the really cool thing is that if I go out of presentation mode, they go back to where they were. So I have two locations for my objects now, where they are in the presentation and where they are in edit mode. So I can be organized in both places. I can make it make sense to me in both areas in terms of what I want the UI to be and what I want the code to be. Presentation mode also locks the same way that edit mode locks, so that now I can interact with the buttons and use them, okay? I can even, if I am looking at the inspector window, there's this P in a diamond next to the search filter right in the center at the top. And if I click that, it's going to show me my patcher inspector. These are properties for my entire patcher, right? So like I can change, is this going to let me change the background on my whole thing? Yeah, I can change the background color to a really like hideous green if I so choose. And the important thing I wanted to show you was down here in view, I can hit open in presentation mode. So now if I were to save this and open it again, my patch is going to default open in presentation mode. So again, if I'm making software for someone else to use, or for me to use during a performance or an event, I'm just going to have it open in presentation mode. I don't need to see the code part, I just need to see the UI. So I can default have it open in presentation mode. And then if I unlock, I think that was just the lock color that I set, that'll go away, that green. So that's kind of fun. Okay. Questions about presentation mode? Great. All right, I also wanted to look at a couple of different inputs. So if we move over to the yellow zone, I'm going to look at keyboard first. Keyboard is a way for me to get information about the keyboard connected to the computer into my Mac's patch. So for instance, if I want to be able to launch audio tracks by people pressing certain keys on the keyboard, I can do that. I can use the keys as buttons. And I just use the key object to do that. It outputs a number. which is the ASCII code of the key that I'm pushing. If I use this other one I to A, which is converting an integer to a character ASCII letter, it'll tell me which key that was, right? So 97 is lowercase a, 117 is lowercase u, 108 is lowercase l, 98 is b. And I've got a select 32 here, right? So if I want to detect which key someone's pressing, like if I want something to happen with a specific key, I can use the select object that we've used for our sequencers, right? Same thing, I'm selecting a specific number. What is 32? ASCII code. I think it's spacebar. Haha, but I have something else set up for the spacebar. Tricky. Let me change that real fast to 27. Oh no, I have 27 is the escape key, but I have that on something else too. Okay, we'll get to that in a minute. So yes, just hit space or escape again if it goes into full screen mode. Okay, so I'm going back to 97 since that was safe. That was lowercase a. So now whenever I press A, I get my toggle there. Or my bang or whatever I want to do with that selection of the A key. So that could be useful if you want a quick way to replicate buttons. Use the keyboard. So now I don't have to click on the toggle with the mouse. I can just use the A key.
Could you use that keyboard to cause your program to recognize a word?
Yes and no. You could, but it would be really complicated. You'd have to like read in letters and save them and then add them together and then compare them to stuff. Yeah.
Oh no.
Yeah, that's a bit more advanced. All right, the other thing I wanted to show you has to do with the motion detection stuff that we looked at last time. My camera's still running. Let me close that. Turn that off. If I connect, actually, yeah, let me just connect the camera to my motion detection. Right, so we've got our quantity of motion happening there. This is cool and useful, right? And so like, if I have a camera set up in a space and someone walks into the frame, like I'll be able to detect them walking into the frame, right? But if someone walks into the frame, like I just did, and stands still, they disappear again, right? What if I want to know if they're there or not?
Oh, you mean set like a picture of the empty room and then look at the difference?
Right, yeah. If I had a frame of the empty room that I could compare this to, then I'd be able to tell that. That's exactly what I want to do. The problem is, we call that background subtraction. To do that, I need to keep a running average of what the background is, because I could, in theory, do this with like a still image shot of the environment. There's a lot of problems with that though. What are some problems I might have if I have a still image of an environment and a camera and I'm subtracting always against this one frame that I have that's my understanding of the environment?
It's dark.
Right, if the lighting changes, my image is no longer good. What else?
The camera.
Yeah, if the camera gets bumped, my image is no longer good. If someone comes in and puts a chair in the frame and that's fine and I don't care about detecting chairs, that also changes the image, right? So there's a lot of problems that I could have with that. So what I really want to do is do a running average. So I want over like 100 or 1,000 frames to be constantly averaging what my background is and detecting that, and then comparing my most recent frame to that running average, this long-term average of the environment. But to do that, I need cv.jit.runningaverage, which is orange. It's not part of my patch. Shoot. So like most programming languages, you can extend Max. You can add stuff to it. Thankfully, Max has a really nice way to do that. If we go to File, Show Package Manager, and we're connected to the internet, it's going to bring up this other window that's going to show us a bunch of libraries that people have built for Max. The one that I want that's very useful is called cv.jit. So I'm going to search for that in the top right. I see it here by Jean-Marc Pelletier. cv.jit. CV stands for... It does, but in this context. Computer vision. Computer vision. And if I click it and then click install, it'll think for a minute, download some stuff, and eventually I should be good. Another package that's really good is called Max for Visual Artists. There are also some machine learning ones that are nice. And so once it's installed, I've got some new options here. I can uninstall, I can disable it if I think it's causing me a problem or something. The launch button is going to bring me up like an index of the help files for the package, so that is useful as well. But we're just going to look at running average for now. Problem is, still orange. If I install one of these things, I have to restart Max to really get it to work. So I'm going to quit that and reopen. Yeah. And now if I look here in my background subtraction, it's now dark gray and light gray like a normal object. So it should work. So to get this to actually do something, to show you how this thing functions, I am going to connect my camera to the first inlet of background subtraction. And just so I can show you side by side how these things work, I'm also going to connect it to motion detection. I'm going to go in and turn my camera on. And then I'm going to open this up so I can look at it as well. All right. So I've got background subtraction and motion detection opened up, and we'll look at the similarities and differences of these. We start here with our matrix and our change, and we get to the RGB to Luma. Background subtraction is also immediately doing an RGB to Luma. It's then converting it to a one plane, because it's just grayscale, float matrix instead of the character matrix. So instead of 0 to 255, this is going to be decimal place numbers. It's going into, and that's going into my CVJIT running average. That has a attribute that I have hard-coded into 0.005, which is the alpha, which is an indicator of the duration of how long it's going to take before it resets its background. So I can change that to be faster or slower with my slider here. And if we look at its output, right, at 0.79, it's doing a very fast average. It's only averaging a few frames, and we can see that it's keeping up with my motions pretty well. Whereas when it's lower, it's going to take significantly longer to figure out what the average is, which is why, like, if I want this in an installation that's checking an environment, I want a very low number, and then it will take a very long time before it figures out that I've moved and I'm in a new spot. Trippy. Then I'm going to do my absolute difference. I don't need the trigger list here because I'm going to send my average as the one that's always getting subtracted from, versus the frame grab, which is going in here. So I'm taking the current frame of the video and subtracting it from this to see the difference, which is what's down here. After that, it's the same process. I do my JIT op greater than with the val to set a threshold, and then I do have to switch it back to a character matrix so that the 3M will work on my 0 to 255 values to get that measure of how much has changed from the background of my patch. Now, if I want to, if like I move and I want to reset my camera, I move my camera around and I want it to really quickly get a new background, I can use this reset alpha bang button and patch, and that will immediately reset the alpha data so it forgets everything that it had before. So, two different things. One is detecting motion in a frame. Background, this one is detecting motion, but also presence, right? So even if I'm not moving, if I'm just sitting here, it's still going to tell me that something is up. Okay, so they have different applications. Then I wanted to show you an output too that is very useful. In our outputs, we've got P window. And this is why the escape and spacebar keys weren't working properly. So I'm using an object called jit.window. And this is what's going to allow me to make something full screen or play a video full screen. So to really show this off, let's connect our video. We've got our dishes video going, and I'm going to connect that to window. And as soon as I do that, we'll notice that my dishes are now playing in this thing called cats. Okay? Why? So my video is coming in here. It's going into JIT window. I'm giving JIT.window a name, cats. So that's this one. This window cats is related to this object. And then I can do some other things. I'm using my key object to detect a key input here. I've got it on select 27. That's the escape key, which is hitting a toggle, which is going to full screen $1. So full screen is an attribute of JIT window I can set. The $sign is capturing this, right? So it's going to be full screen 1 or full screen 0, which is full screen on or off. So if I hit the escape key, we get the dishes full screen. I can also toggle things like if I want the menu bar in full screen. Hey. Oh. That's odd. I'm not sure why that's not working. But it should either show or hide this menu bar. I also might want to turn on anti-aliasing if I'm going full screen, which will help with some of the pixelation that you might get if you're throwing a low-res video up at a very large size. Questions about any of that stuff so far?
Maybe videos in this too.
Yes. And, okay, just a few more things. I wanted to look at some logic things too. All right. In the orange box, logic. These are also some basics. Someone asked earlier, how do you fine tune that motion range, right? I'm getting it out and it's making my zoom go crazy. If I look at the scale object, this is one of the most useful objects in Max. You'll find you're using this all the time. It lets me scale from one range of numbers to another, and I can scale between integers and floats, or floats and integers, or integers and integers, whatever I want to do. And the format is like this. So I say scale. I give it the expected low range of my input, the expected highest value of my input, and then the lowest value that I want from my output, and the highest value I want from my output. So looking at this scale object, I'm saying I'm going to take a number. That number is going to be an integer that I expect to be between the range of 0 to 127. And I would like you to map that to a different range of floats that are from 0 to 1. So I could take, if I put a 0 into this, what am I going to get out? Right. If I put 127 into this, what am I going to get out? If I put around 63 into this, what am I going to get out? Right. So let's see, 63.496. Nice. 7.055. 100.787. Okay. This is very useful for mapping ranges of values. So like that motion value might only be between like 0 and 0.1, and I want to scale that up dramatically to a full 0 and 1. I can do that with this object. And it will expand its range too. So for instance, what happens if I give this negative 60? Yeah, so even though that's outside of my input range, it will try to figure out what I would want based on that. This can get tricky if I give it like something, like what if I give it 200? That's even more than my range. Right, now I'm going to get 1.5 something. That can be problematic if I really wanted this to stay within the 0 to 1 range. There are two ways I could deal with that. One is to use an object called ZMap. And now if I exceed my range here, it's never going to go above my output range. If I go below, it's never going to go less. Yeah. So ZMap is like a scale that has a built-in clipping on there. I can also use something called clip, which will limit my numbers to a certain range too. It won't let anything go above that. Or outside of that range. Okay, that's scale. Another thing that might be useful to you are gates and switches. So this is if we've been working with like continuous ranges, like we've got a range of motion and we're going to map that to a rate or a playback speed or volume level or something like that. What if we want it to go one way or another? I'm going to turn on my metros, and we see I've got bangs. Both of these going at this 200 rate, right? Because my metro, this one comes in here and out here. That's a gate, a G gate. I've got a G switch, comes in here, goes out there. Now I can flip these, right? So my gate is going to let me send one input to different locations. So now it goes out this way.
So like reroutes it.
It reroutes it, yeah. Whereas my switch is going to say, let me take multiple inputs and send them to one output. So this one is going to switch between my Metro 200 and my Metro 800, depending on what I want to do. These help you control like the flow of information through your patch. All right, and let's look at compare listens. So these are like some of our math objects, right? I can compare two numbers, greater than, less than, equals, not equals, these kinds of things. So if I give this one 5 and I give this one a 7, is that true or false? It's true. I get a 1. Yay. If I give it 4, is it true or false? False. I get a 0. Okay, so it turns off my toggle. I can do this dynamically by dragging this number around. The problem, though, we'll see is if I change the number on the other side of the equation, nothing happens, right? Because, again, this is my hot outlet. This one's cold. It's only going to redo my evaluation when this one changes. I could use trigger to make it do it when either of them change. How does that work? So I'm setting my number here. It's going into trigger, bang, integer. The integer comes out first here. And then I'm not sending the integer over here because that would be comparing the number to itself. I'm just sending a bang out here. So it's sending an integer here to reset the comparison value and then banging this so it reprocesses with whatever number it had from before. So now dragging either of these will let me control that one. An issue that you'll run into with using these, for instance, if I had one of these connected to motion detection, like if my motion detection is greater than 0.1, I want something to happen. It is constantly evaluating, right, whether it's true or false. So I've got my metro connected to a 0, going to is that greater than 10? And this is constantly telling me no, no, no. Every 300 milliseconds, it's saying no. It's not greater than, it's not greater than, it's still not greater than, guess what? It's not greater than. As often as I send that, it's going to tell me it's not greater than. So, like, again, if I'm doing motion detection and I've got that coming out at like 30 frames a second, it's just going to be saying no, 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 no. Which makes it difficult for me to tell if I want something to play once, right? So if this is greater than 10 and I want to play an audio file, I connect my SF play to this. What do you think is going to happen? It's going to be terrible. Because it's going to play, it's going to get the play over and over and over again. Let me see if I can do this really quickly. Yeah. Oh, I also need right. Da 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 da. That's not the behavior I want, right? As entertaining as that may be, it's not what I'm going for. I want it to just play once when my value is greater than 21, and then stop when it is less than, and then just play once, right? This is a very common logic problem you run into with Max. So we can use the change object to filter out the excess ones. So change is only going to give us an output if the number it's receiving changes. So from my toggle, change is only going to receive zeros and ones, and it's only going to output that number when it changes. So if we watch, it looks like it behaves the exact same way as the one above it, right? But if we notice when it bangs, it's only banging once at the moment the value changes. It's not constantly giving us that feedback. So if we connect our audio player to this one, it only plays it once. All right, so it's like a filter. It's saying like, okay, I understand that you want to tell me every evaluation you're doing, but I only care about the number if it changes. It's the exact same thing that we're doing in motion detection with jit.change, except we're just doing it on one number instead of a whole matrix of numbers. Okay.